What if everything we know, everything we see, and everything we believe about reality is just a fragment of something far greater, something so vast that our minds can barely begin to comprehend it? For centuries, humans have looked up at the stars, convinced that the universe we see is all there is. Yet modern science and bold speculation tell us otherwise. The truth may be stranger than science fiction. Beyond the galaxies that light our skies, beyond the cosmic horizon that marks the limit of our vision, lies a realm of possibilities that challenge everything we think we know about existence. The universe, as incredible as it already appears, may be only a single page in an infinite book, and each page could reveal an entirely new reality, one where the rules of physics are different, one where countless versions of ourselves are living out other possibilities, or one where nothing exists at all. This isn't just theory for scientists in labs or philosophers in deep thought. It's a journey that touches each of us because to wonder what lies beyond the universe is to confront the biggest question of all. Why are we here, and what does it mean? As you'll see, every answer opens the door to another mystery. Every certainty dissolves into deeper speculation, and the more we learn, the more we realize just how little we know. But what if the scariest truth isn't that the universe is endless, or that there are infinite copies of us scattered across dimensions, but that we might just be living inside a carefully constructed illusion? Stick with me, because the deeper we go, the more the lines between reality and imagination blur, and what comes next will challenge everything you thought was possible. When we think of the universe, we often imagine the stars we can see, the galaxies photographed by telescopes, or the swirling bands of the Milky Way stretching across the night sky. But here's the thing. Everything you've ever seen, every shining star and glowing nebula, is just a tiny slice of what scientists call the observable universe. And that phrase is important, because it reminds us that there's a fundamental limit to how far we can look, a cosmic horizon that separates what's visible to us from what remains hidden forever. Imagine standing on a beach, staring out at the endless ocean. No matter how sharp your eyes are, you can only see as far as the horizon allows. Beyond that line, ships can sail, storms can rage, and entire continents could exist. But to you, they remain invisible, hidden by the curve of the Earth. The universe works in a similar way. Our horizon isn't shaped by oceans or curves, but by time itself. You see, the universe is about 13.8 billion years old, which means the farthest light we can possibly detect has had 13.8 billion years to travel before reaching us. That distance forms a kind of shell around us, or an ultimate boundary of vision. But here's where it gets fascinating. The expansion of the universe has stretched space itself, so what we can observe is now about 46 billion light-years in radius. That's our observable universe, a sphere around us filled with countless galaxies, stars and mysteries, but still only a fraction of what might exist. Now here's the part that sends chills down the spine. That cosmic horizon isn't a real wall or barrier. It's not like you'd crash into it if you flew far enough. It's just the edge of what light has had time to reach us. Beyond it, the universe could stretch on infinitely, with galaxies, stars, and maybe even entire civilizations we'll never be able to see. Think about that for a second. Every time you look at the stars, you're not just looking at faraway suns, you're peering into the past because their light has taken years, centuries, even millennia to arrive here. A star 1,000 light-years away, you're seeing it as it was 1,000 years ago. Now imagine looking at the edge of the observable universe. That light has travelled for almost 14 billion years, meaning what we're seeing isn't what those galaxies look like today, but what they looked like at the dawn of time. And because the universe has been expanding ever since, many of those galaxies are now so far away they've slipped beyond our reach forever. It's like watching a ship disappear over the horizon. You caught a glimpse of it, but it's gone for good. This is where the concept of the observable universe becomes more than just science. It becomes existential. If everything we know is inside this bubble of visibility, then what lies outside it? Is it just more of the same, endless galaxies stretching forever? Or does something entirely different begin beyond the horizon, something we can't even imagine? Some scientists suggest that the universe could be infinite, a never-ending expanse where the observable part is nothing more than a speck. If that's true, then there's not just one Earth, but infinite Earths, Infinite versions of you watching this very moment, maybe with tiny variations, maybe with completely different lives. Others argue that the universe might be finite but unbounded, like the surface of a sphere. You can travel forever without hitting an edge, but the space you're moving through still has limits. Both ideas are dizzying, and both highlight the fact that the horizon we see is not the ultimate edge, but just a trick of time and light. To bring this home, think about how fragile our sense of scale really is. We look at the night sky and feel small compared to the vastness of space, but in truth, even that vastness is small compared to what likely exists beyond our cosmic horizon. Imagine there are galaxies out there so distant that their light will never reach us, no matter how long we wait, because space between us is expanding faster than light can cross it. These galaxies are effectively erased from our reality, existing in a universe we can never access. And yet they are out there. Stars are being born, civilizations might be rising and falling, and we will never know. This realization is humbling, terrifying, and awe-inspiring all at once, and it doesn't stop there. The horizon is constantly evolving. As time moves forward, light from previously hidden regions slowly becomes visible, revealing new galaxies that were once out of reach. But at the same time, expansion means other galaxies are slipping away, lost forever. It's as if the universe is playing a game of give and take, showing us glimpses of its secrets while hiding others permanently. We are caught in the middle, observers in a universe that both reveals and conceals itself in equal measure. It raises a haunting question. What if the most important truths about existence lie forever beyond that horizon, just out of reach, teasing us with their possibility but denying us their reality? This is why scientists often compare the observable universe to a kind of prison of perception. We are locked inside a bubble of visibility, unable to see beyond its edges, and just like a prisoner who doesn't know what lies outside their cell, we can only imagine. But maybe that imagination is the most powerful tool we have. Maybe the very fact that we can ask these questions means we're meant to push against the limits of understanding, even if we never break free of them. And that's where the story becomes not just about what's out there, but about us, our curiosity, our drive, our refusal to accept limits. Because the truth is, the universe doesn't care what we can or cannot see. It simply exists, vast and unending, while we stand on our tiny planet and try to make sense of it. That's the power of the horizon. It reminds us that there is always more beyond what we know, more beyond what we can see, and more beyond what we can even imagine. And if that thought leaves you unsettled, good. It should. Because the greatest mysteries of existence are not behind us. They are waiting just beyond the horizon, daring us to wonder, daring us to keep searching, and daring us to accept that reality is always larger, stranger, and more astonishing than it first appears. If the horizon of the universe already leaves us stunned, then the way that horizon changes over time takes the mystery even further. Because the universe isn't static, frozen, or fixed in place. It's expanding. Space itself is stretching, pulling galaxies apart, and the farther away those galaxies are, the faster they seem to recede. It's a phenomenon that was first noticed when astronomers studied the light of distant stars and galaxies and saw that it was shifted toward the red end of the spectrum. This redshift wasn't caused by the galaxies physically moving through space, like cars driving down a road, but by space itself expanding between them and us. Imagine dots drawn on the surface of a balloon. As you inflate it, the dots all move farther apart, not because the dots are moving on their own, but because the surface they sit on is stretching. That's our universe, a cosmic balloon that's been inflating since the Big Bang, with galaxies carried outward by the fabric of space. Now, here's the staggering part. The expansion isn't slowing down, it's speeding up. Instead of being pulled back by gravity, as one might expect, galaxies are being driven apart faster and faster by something scientists call dark energy, a mysterious force that makes up roughly 70% of the universe. We don't know exactly what dark energy is, but we can see its fingerprints everywhere, pushing galaxies away at rates that defy intuition. What this means is that every second the universe gets bigger, the distances grow, and the horizon shifts. Galaxies that are visible to us today will one day slip out of sight forever, as they recede faster than the speed of light can carry their glow back to us, And before you pause on that, yes, space itself can expand faster than light. It doesn't break Einstein's rules, because those rules apply to objects moving through space, not to space itself. The expansion of the universe is like an ever-stretching stage, carrying everything with it whether we notice or not. Think of it this way. Imagine standing in the middle of a vast plain, watching campfires burning in the distance. Each fire represents a galaxy. At first, you can see them clearly, but then the ground beneath your feet begins to stretch. Slowly, the campfires get farther away. One by one, the light from those fires fades until only the closest ones remain. That's what is happening to us. In the far future, perhaps tens of billions of years from now, if humanity still exists, the night sky will look far emptier than it does today. The great clusters of galaxies that now inspire wonder will be gone, their light stretched away into nothingness, leaving future observers trapped in a dark and lonely universe, unaware of the incredible cosmos that once surrounded them. But right now, in this moment, we are privileged. We live at a time when the universe is still open to us, when our telescopes can still peer across billions of light years and catch glimpses of those distant fires before they vanish. We are like travellers who've arrived at a mountaintop just in time to see the last rays of sunset before night falls. The beauty is fleeting, and the knowledge that it will disappear makes it even more precious. The expansion of the universe isn't just a scientific curiosity, it's a countdown, a reminder that our ability to witness the cosmos has an expiration date. That urgency gives weight to our quest to explore and understand, because the universe we see today won't always be there tomorrow. And yet, even as galaxies recede, there is something hauntingly poetic in the thought that their light is still streaming toward us, carrying with it ancient messages from a time when the universe was young. Every photon of light we catch from those faraway galaxies is a relic, a traveller that has crossed unimaginable distances, stretching and weakening as it moves through space. When it finally enters our telescopes, it tells a story billions of years old, whispering of worlds we will never touch and events we can never witness. The expansion of the universe ensures that much of what it shows us is already gone, erased from the present even as we glimpse its past. We are seeing ghosts, echoes of a reality that no longer exists. This leads to a profound paradox. The more we look outward, the more we're really looking backward in time. The galaxies we see at the edge of the observable universe are snapshots of the infant cosmos, frozen in the act of becoming. But the galaxies that exist in those places today are already lost to us, pushed away faster than their light can return. The universe isn't just expanding, it's erasing itself from our sight. And this erasure raises questions that go beyond science into philosophy. If realities exist beyond our horizon, but we can never see them, never touch them, and never know them, do they truly exist for us? Or are they forever beyond the scope of our reality, as though they might as well not exist at all? This is where expansion becomes more than just an astronomical fact. It becomes a mirror for our own condition. Human beings crave knowledge, but the universe itself places limits on how much we can have. It's as if the cosmos teases us, offering glimpses of the infinite but always pulling the curtain closed before we can step through. The expansion is relentless, and no technology, no future telescope, no clever trick will ever allow us to see past that ultimate horizon. We are trapped in a bubble of visibility, watching as its walls slowly shift and change, revealing new sights even as others fade away. It is both a gift and a curse. A gift because we live in a time when so much remains visible. A curse because we know that so much more lies forever out of reach. But perhaps the most haunting thought of all is this. What if the expansion isn't uniform? What if other regions of the universe, beyond our view, obey different rules, shaped by different balances of energy and matter? What if galaxies beyond the horizon aren't just distant, but fundamentally alien in ways we cannot fathom? The accelerating expansion ensures we will never know for certain. All we can do is speculate, dream, and imagine what lies in that unreachable expanse. And here's the transition that keeps the story moving. Expansion doesn't just point to galaxies slipping away. It opens the door to even stranger possibilities. Ideas that suggest the universe itself might not be alone. That what we think of as everything could be just one piece in a cosmic puzzle stretching into infinity. Because if space can expand without end, then perhaps there's no limit to how many versions of reality exist. And the thought that there could be other universes, other worlds, and even other versions of ourselves is where the mystery of expansion turns into something even more astonishing. If the expanding horizon shows us that much of the universe will eventually vanish from sight, then the next question becomes unavoidable. Does the universe actually end, or does it go on forever? This is where the idea of the infinite universe comes in, and it's one of the most mind-bending concepts humanity has ever grappled with. Imagine walking through a forest that stretches endlessly in every direction. No matter how far you go, the trees never stop, the landscape never opens up, and the horizon never resolves into an edge. That's what an infinite universe would be like, an endless expanse of galaxies, stars, and planets, with no boundary, no final wall, no ultimate edge where everything stops. The observable universe, that 46 billion light-year bubble we can see, would then be nothing more than a tiny patch, an insignificant neighborhood in a cosmos so vast that it makes our entire reality feel like a single grain of sand lost in an endless desert. Here's where the concept becomes even more staggering. In an infinite universe, every possible configuration of matter has to exist somewhere. Just as rolling dice enough times guarantees that every combination will eventually appear, the random scattering of particles across infinite space means that every possible outcome will occur. That includes not just galaxies and stars, but entire planets that look exactly like Earth. In fact, the laws of probability suggest that there would be infinite Earths, infinite solar systems, and infinite versions of you. Somewhere out there, another version of you is living your life almost exactly as you are now, but with tiny differences. Maybe they're wearing a different shirt. Maybe they turned left this morning instead of right. And somewhere else, there's another version of you who made a major life choice differently, took a different career, stayed in a relationship you left, or lived in a city you've never even visited. The unsettling part is that in an infinite universe, these aren't just possibilities. They are certainties. Every choice you've ever imagined exists in some corner of infinity, carried out by another version of you who made that decision. This idea isn't just fantasy, it's mathematics. In an infinite universe, particles can only arrange themselves in so many ways before patterns start repeating. Imagine a deck of cards. Shuffle it enough times, and eventually the order of cards will repeat, simply because there are only so many possible combinations. Now scale that idea up to infinity, and you start to see the implication. The universe doesn't just contain random galaxies. It contains repeating structures. It contains planets identical to Earth. It contains histories identical to ours. And given infinity, it contains them not just once, but countless times over. Somewhere out there, another you is reading these exact same words, living in a world indistinguishable from this one. But this is also where the beauty of the idea collides with the terror of it. Because if every possibility exists, then the darker ones must also be real. There are versions of Earth where catastrophes wiped out humanity centuries ago. There are versions of you who lived shorter, harsher lives. There are universes where wars never ended, where plagues never healed, where progress never came. Infinity doesn't discriminate. It doesn't give us only the good. It gives us everything. The beautiful and the horrific, the miraculous and the tragic. And in that endless repetition, you start to wonder, what does individuality mean? If there are infinite versions of you scattered across an infinite expanse, then is this you, the one sitting here now, special? Or are you just one echo among countless others, repeating forever? Some philosophers argue that this question cuts to the heart of existence. If every possibility is realized somewhere, then maybe our choices don't matter at all, because for every decision you make, another version of you makes the opposite one. From that perspective, free will seems like an illusion, swallowed up by the inevitability of infinite variation. But others see it differently. They argue that our choices matter, precisely because they shape this reality, this one thread of existence that belongs to you alone. The fact that other versions exist doesn't diminish your life any more than knowing there are billions of stars diminishes the brightness of our sun. If anything, it makes life more precious because among the endless possibilities you're living this unique strand of reality, and no one else can live it for you. Now, the infinite universe isn't just speculation. Some cosmologists argue it's the simplest explanation for what we observe. If space is truly flat, as measurements of the cosmic microwave background suggest, then it might not curve back on itself to form a closed shape. It might just go on and on without boundary. In that case, infinity isn't just possible, it's inevitable. And while we'll never see beyond our horizon, the math points toward a reality far bigger than our limited perspective. Infinity may sound like a fantasy, but in physics, sometimes the simplest explanation is also the most profound. Still, infinity is hard for our minds to process. We're used to beginnings and endings, to boundaries and edges. To imagine a universe with no end is to confront something beyond human intuition, something that stretches not only space but imagination itself. And that's why this idea doesn't just challenge us scientifically, it challenges us emotionally. Infinity forces us to question the meaning of identity, the value of choice, and the uniqueness of our place in the cosmos. It forces us to confront the possibility that we are both infinitely small and infinitely replicated, significant and insignificant at the same time. But here's the twist that keeps the mystery alive. Not all scientists agree that infinity is the answer. Some argue that the universe might be finite after all, limited in size, shaped by factors we don't yet understand. And if that's true, then the story changes dramatically. No longer are there infinite versions of you, infinite Earths, infinite histories. Instead, reality becomes rarer, more precious, and perhaps even lonelier. The question of whether the universe is infinite or finite isn't just a mathematical one, it's a philosophical one. Because the implications change everything about how we see ourselves, and this is where the story naturally begins to pivot. Because if infinity suggests endless versions of us, then what about the possibility that there are entire other universes separate from ours, with laws of physics so different that they barely resemble what we know? If the observable universe is just a bubble, maybe it's not the only one. Maybe our universe is floating in a sea of universes, each bubbling into existence, colliding or vanishing unseen and unimaginable. If infinity already challenges the boundaries of our imagination, then the possibility of other universes takes the challenge to an entirely new level. And that's where our journey continues. If the idea of an infinite universe feels overwhelming, the theory of eternal inflation pushes things even further, suggesting that our universe might not be the only one at all, but rather just one bubble floating in a vast cosmic foam. To understand this, we need to step back to the earliest moments of existence, right after the Big Bang. Scientists believe that in those first fractions of a second, the universe underwent an incredible growth spurt called cosmic inflation. In less than the blink of an eye, it expanded exponentially, smoothing out space and scattering matter in a way that allowed galaxies to eventually form. But here's the twist. Some physicists argue that inflation never really ended. Instead, it kept going in other regions beyond our horizon, creating bubble after bubble, each one forming its own universe with its own beginning. Our universe, the one we know and see, is just one of those bubbles. Now imagine boiling water. As it heats, bubbles form and rise, each bubble a pocket of steam in a larger pot. Eternal inflation suggests the cosmos works the same way, except the bubbles aren't steam, they're entire universes, and just like bubbles in boiling water, they expand, collide, and sometimes merge. If that's true, then our universe is just one bubble in an infinite froth of realities, each sealed off from the others by a kind of cosmic barrier. Inside our bubble, we see galaxies, stars, and the laws of physics we're familiar with. But inside another bubble, the rules could be radically different. One universe might have no gravity, another might have no atoms. Still another might exist in dimensions we can't even imagine. This idea isn't just abstract speculation. It has consequences that could, in theory, leave traces in our own sky. Scientists have proposed that if our bubble ever collided with another one in the distant past, it might have left scars, strange patterns in the cosmic microwave background, the faint afterglow of the Big Bang. Some researchers have claimed to see unusual circular features in that radiation, though the evidence isn't strong enough to prove anything yet. But even the possibility is electrifying. The idea that the oldest light in the universe might carry the fingerprint of another universe brushing against ours, like two soap bubbles briefly touching before drifting apart. And here's where the idea turns deeply philosophical. If there are countless bubble universes, each with its own laws of physics, then our own existence might not be as special as we once believed. Life as we know it requires a very specific balance of forces: the strength of gravity, the charge of the electron, the expansion rate of the universe itself. If any of those values were even slightly different, stars might never have formed, atoms might never have bonded, and life might never have arisen. The multiverse offers a provocative answer to this mystery. In an infinite froth of universes, every possible set of physical laws exists somewhere. Ours just happens to be one where conditions lined up perfectly for life. That's not luck or design, it's statistics. Given enough universes, improbable outcomes become inevitable. But this explanation comes at a cost. If the multiverse is real, then much of science as we practice it could be limited. In our universe, we rely on experiments and observations to test theories. But if other universes exist beyond our reach, sealed off from ours, how could we ever confirm them? The multiverse might be the ultimate explanation, but it could also be forever beyond our ability to prove. It leaves us staring at the night sky with the unsettling realization that we might be living in one bubble among countless others, with no way to ever peek outside. Of course, the multiverse isn't without its critics. Some scientists argue it's not science at all, but philosophy dressed in physics, because a theory that can't be tested or observed directly doesn't meet the standard of scientific inquiry. Others counter that just because we can't test it now doesn't mean we never will. Technology and understanding evolve. What seems unreachable today may one day leave subtle fingerprints we can detect. After all, the cosmic microwave background was once invisible to us, and now it's one of our most powerful tools for understanding the birth of the universe. Who's to say that the multiverse won't leave behind clues we haven't yet learned how to see? But beyond the debate, the imagery of eternal inflation and bubble universes grips our imagination. Picture it. Endless realms, each sealed off, each with its own story. Somewhere out there, a universe exists where stars never formed, where eternal darkness reigns. Somewhere else, there may be universes where time itself works differently, running in loops or branching in directions we can't comprehend. And somewhere else still, there may be universes filled with life unlike anything we know, thriving under rules of physics we could never survive. The sheer diversity is staggering, and it forces us to confront just how small our bubble really is. And then there's the haunting possibility of what happens if bubbles collide. Our universe has been expanding for nearly 14 billion years, growing larger with each passing second. But what if, at some distant edge, another bubble is racing toward us? If two universes were to collide, the results could be catastrophic, rewriting the very fabric of reality. We might never see it coming until the very end. To us, it would look like an unstoppable wall of destruction sweeping across the sky, faster than light, erasing everything in its path. It's the kind of thought that sends shivers down the spine. A reminder that in a multiverse, even our universe might not be permanent. Still, eternal inflation does more than scare us. It humbles us. It suggests that our universe is not the whole story, but just one chapter in an infinite library of realities. And perhaps that is why the theory resonates so deeply. It doesn't just challenge our science, it challenges our sense of place. For centuries we believed Earth was the center of everything. Then we learned we orbit the sun. Then we learned the sun is just one star among billions in a galaxy that is itself just one among trillions. Eternal inflation takes that humbling lesson to its ultimate conclusion. Not only is our galaxy not the center, not only is our universe not unique, but it may not even be alone. We are one bubble in an endless froth, one reality among countless others, each expanding, colliding, and drifting in a cosmic sea we can never fully map. And if that thought leaves you unsettled, good, it should. Because the universe, or perhaps the multiverse, isn't here to comfort us. It's here to remind us of mystery, of possibility, of scale. The story of eternal inflation doesn't just tell us that we're small. It tells us that reality itself may be larger, stranger, and more astonishing than we ever dared to dream. And as we leave behind the image of our bubble floating among countless others, the natural question becomes, what happens inside each one? What realities unfold when the very fabric of existence splits into endless branches, each carrying forward every possible version of every possible choice? That's where the journey leads next. into the shadowy world of quantum possibilities and the chilling thought that every decision we make creates another universe where the opposite choice was made. If eternal inflation dares us to imagine countless universes bubbling into existence, then quantum mechanics pushes the idea into even stranger territory, suggesting that every single moment of your life is already branching into endless versions of reality. This is the many worlds interpretation, and it's as chilling as it is fascinating. At its core, quantum mechanics is the science of the very small, the strange rules that govern particles like electrons and photons. Unlike the predictable motion of planets or the reliable ticking of a clock, particles exist in a state of uncertainty, a haze of possibilities where multiple outcomes overlap at once. For example, an electron can spin in two directions at the same time, or a photon can pass through two slits simultaneously. It's only when we observe them that they choose one outcome. But according to the many worlds interpretation, the particle never actually chooses. Instead, every possible outcome happens, but in different branches of reality. The universe splits, one version where the electron spins up, another where it spins down, and both are equally real. Now take that eerie rule of the quantum world and apply it to life. Every decision you've ever made, what school to attend, who to date, whether to say yes or no, splits the universe into branches. In one world you took the job offer, in another you walked away, in one you missed the train, in another you caught it. Somewhere out there, every possibility you've ever imagined, and countless you never considered, exists in another version of reality. There are universes where your life unfolded almost exactly the same, but with tiny differences. A conversation that never happened, a friendship that ended sooner, a chance encounter that changed everything. And then there are universes where your life is unrecognizable, shaped by one decision that spun the story into an entirely different direction. The unsettling part is that this branching doesn't just happen with big choices, it happens constantly, with every quantum event. At every instant, reality splits into countless versions, endlessly multiplying. That means there are versions of you who never existed in this world, because a particle in your parents' DNA spun a different way. Versions of Earth where history took a wildly different path because of the outcome of a single tiny event. Imagine universes where ancient civilizations never fell, where world wars never began, or where technological revolutions happened centuries earlier. The many worlds interpretation paints a picture of reality as an infinitely branching tree, with every possible path existing somewhere, endlessly sprawling in directions we'll never see. But here's where the theory becomes more than just science. It becomes terrifyingly personal. Because if every possibility exists, then so does every possible tragedy. There are universes where the worst things that could happen to you already have. There are universes where you lost someone you loved sooner, where you never recovered from a setback, where everything went wrong. And just as unsettling, there are universes where things went far better, where you achieved every dream, avoided every mistake, and lived a life beyond your imagination. The many worlds interpretation doesn't just multiply outcomes, it multiplies emotions, joys, heartbreaks, and lives. And yet, we are only aware of this one branch, this one reality, the version of the story unfolding right here and now. This raises the question, what makes this branch special? Why are we aware of this version of reality and not the others? Physicists and philosophers debate endlessly about whether consciousness itself plays a role in selecting which branch we experience. Some suggest that our awareness rides along one path, while others insist that all versions of us are equally real, equally alive, and equally unaware of the others. From that perspective, the you reading this isn't more authentic than the you who never clicked play, or the one who turned off the video halfway through. Every version is as real as the next. You're not unique in the way you think. You're simply one variation in an infinite chorus of selves. Now, the many worlds interpretation isn't the only way to understand quantum mechanics, but it is one of the boldest. Some scientists argue it's the cleanest explanation because it doesn't require particles to decide when they're observed or collapse into a single outcome. Instead, all outcomes exist, and the universe simply keeps splitting. The math works, but the implications are staggering. It suggests that reality itself is far stranger than our senses allow us to perceive, a vast and endless web of branching possibilities where everything that can happen does happen, of course. Not everyone is comfortable with this view. Critics argue that the many worlds interpretation is untestable, that it multiplies universes unnecessarily, and that it stretches science into the realm of philosophy. But even skeptics admit that quantum mechanics itself is undeniably strange. Experiments have shown particles behaving like waves of probability, existing in superpositions, and even becoming entangled across vast distances, instantaneously affecting each other in ways that defy common sense. The quantum world refuses to play by the rules of classical physics, and the many worlds interpretation is one attempt to make sense of the chaos. Whether or not it's true, it forces us to confront the possibility that our everyday reality might be just one thin thread, woven into an unimaginably complex tapestry. And here's the thought that lingers long after you first hear about it. If countless versions of you exist, each living out different possibilities, then what does that mean for choice, responsibility, or even destiny? Do your decisions matter if somewhere else another version of you is making the opposite one? Or do they matter even more because they define this version of reality, the one you experience, the one you control? Some find comfort in the idea that their failures are balanced by other selves who succeeded. Others find it horrifying, a loss of uniqueness, a reminder that even your most personal experiences may not belong only to you. Still, there's something strangely beautiful about it too. If the many worlds interpretation is true, then every dream you've ever had, every what-if you've ever wondered exists somewhere. There is a version of you who lived that life, who took that risk, who said yes instead of no. In a way, the many worlds interpretation makes reality feel richer, as though nothing is ever truly lost, only lived out in another branch. And while we may never touch those other lives, the thought that they exist makes this one feel all the more precious. Because at the end of the day, this is the only branch we can know. The only life we can live is the one unfolding before us, with its mix of choices, chances, joys, and heartbreaks. The many worlds interpretation may tell us that reality is infinite, branching endlessly into directions we'll never see, but it also reminds us to cherish this singular path, this one version of existence we get to experience, and as unsettling as it is to imagine countless versions of yourself scattered across the multiverse, it's also inspiring. It means that reality is bigger, stranger, and more creative than we could ever imagine. It means that the story doesn't end here. It never ends. Every moment is a doorway to another universe, and every choice is a spark that lights up another path. And just when you think it couldn't get stranger, another theory emerges, one that doesn't just say the universe splits into branches of possibility, but that the universe itself might not be physical at all. Instead, it could be made of pure mathematics, a cosmic equation where reality isn't just described by numbers, but is numbers. And if that's true, then our universe might not be the ultimate stage for existence. It might just be one formula among an infinite library of mathematical worlds. If the many worlds interpretation already stretches the imagination, then the idea of a mathematical universe takes it even further, stripping away everything we think of as solid and insisting that at the deepest level of reality, we are living inside numbers. To most of us, mathematics is a tool, a way to describe the orbit of planets, the rise of populations, the flow of money, or the structure of music. But to some physicists and philosophers, mathematics isn't just a language we invented to describe the universe, it's the foundation of the universe itself. According to this view, numbers don't just model reality, they are reality. Every equation, every pattern, every geometric structure isn't just abstract, it's the substance from which our universe is made. This idea was most famously proposed by physicist Max Tegmark, who suggested what he called the mathematical universe hypothesis. In his view, the universe exists because it is a mathematical structure. Just as a triangle exists whether or not anyone draws it, so too does the universe exist as a self-consistent mathematical object. In other words, reality doesn't just follow the rules of math, it is math. We are not made of particles in the way we usually think. We are made of relationships between numbers, woven together into a self-sustaining equation. It's an unsettling thought, because it takes everything familiar, our bodies, our world, even the stars, and reduces them to abstract information. Yet when you consider how deeply mathematics underlies everything we know, it starts to feel less like philosophy and more like a genuine possibility. Think about it. The laws of physics are written in math. Gravity, electromagnetism, quantum mechanics, all of them are expressed through equations. Music is built on ratios of frequency. The spiral of a seashell follows the Fibonacci sequence. Galaxies spin in patterns predicted by geometry. Everywhere we look, math is not just present, it is unavoidable. We can't step outside it, we can't imagine the universe working without it, and we can't find anything in nature that contradicts it. That universality begs the question, is math simply the language of the cosmos, or is it the cosmos? Now imagine this, if the universe really is a mathematical structure, then it might not be unique. Just as there are countless possible equations, there could be countless possible universes, each one built on a different mathematical foundation. Some might be similar to ours, with familiar particles and forces. Others might be utterly alien, with shapes, dimensions, and patterns we cannot comprehend. We might live in one formula among an infinite library of mathematical worlds, each one as real as the next, each one existing simply because it can. From this perspective, our universe is not special or chosen. It's just one consistent solution to the problem of existence. The implications of this are staggering. If everything is math, then our perception of reality is just an interface, a way of experiencing the deeper equations beneath. Imagine a video game character. From their perspective, their world is filled with trees, rivers, and skies. But underneath, their reality is nothing but code, strings of numbers and rules that generate the world they see. According to the mathematical universe idea, we are no different. We experience matter, time, and space, but beneath it all is an intricate web of mathematics that doesn't just describe reality, it creates it. And just as a video game world doesn't need to know about the programmer who wrote it, our universe doesn't need a creator beyond the math itself. The equations simply exist, and because they exist, so do we. This theory also provides a strange kind of immortality. If mathematics is eternal, then so is the universe. Numbers don't vanish. Equations don't fade. They are timeless truths, existing outside space and time. That means that even if our physical universe were to collapse, the mathematical structure that defines it would still exist in some sense. It would remain in the realm of pure math, eternal and unchanging, a cosmic blueprint that can never be erased. But of course, not everyone is convinced. Critics argue that just because math describes reality doesn't mean it is reality. They point out that maps describe landscapes, but maps aren't landscapes themselves. Numbers can model a tree, but numbers aren't the tree. To these critics, the mathematical universe is an unnecessary leap, turning abstraction into existence without proof, and yet the counter-argument is hard to shake. What if the only reason we can describe everything with math is because everything really is math? What if the tree, the landscape, and even the map are all built from the same underlying code? There's also the unsettling question of what it means for us as conscious beings. If we are mathematical structures, then so are our minds. Our thoughts, our emotions, our memories, all of them could be patterns of information, computations running on the fabric of math itself. In one sense, this diminishes our uniqueness, reducing us to algorithms, but in another sense, it elevates us. Because if consciousness can arise from mathematics, then maybe it's not rare at all. Maybe wherever the right equations exist, awareness can bloom. That means consciousness could be scattered throughout the mathematical multiverse, not limited to biology, not tied to matter, but as fundamental as the numbers themselves. And yet perhaps the most haunting aspect of the mathematical universe is that it leaves no room for mystery beyond math. If everything is numbers, then the universe is inevitable, complete, and inescapable. There is no need for meaning outside the equations, no purpose beyond the structure. We exist because the math works, and we continue because the math is consistent. To some, this is liberating. It removes the need for supernatural explanations. To others, it's terrifying. It reduces existence to a cold, impersonal system where wonder is replaced by inevitability. But even in that coldness, there is beauty. Because if reality is mathematics, then beauty itself, the symmetry of equations, the elegance of formulas, is woven into the very fabric of existence. Now, where does this leave us? If the universe is mathematical, then exploring it means uncovering its equations, solving the puzzle piece by piece. And that's exactly what physics has been doing for centuries. From Newton's laws to Einstein's relativity to quantum mechanics, every step has brought us closer to seeing the blueprint beneath the world, but the blueprint is incomplete. We don't yet have a theory that unites quantum mechanics with relativity. We don't yet understand dark matter or dark energy. If the mathematical universe is real, then the final equation is still out there, waiting to be discovered, a formula that explains everything. And the search for it may be the closest thing humanity has to a quest for ultimate truth. And just when you think this theory has reached its limit, it offers one more twist. If math is the foundation of reality, then the possibilities of existence are endless. Every consistent mathematical structure could correspond to a universe. That means there are universes where time is circular, universes with 10 dimensions, universes with no space at all, universes we couldn't even describe because our math isn't advanced enough to imagine them. We're not just one universe among many, we're one equation among infinite equations. And if that doesn't make your head spin, nothing will. As we leave behind the notion of a mathematical universe, the next step in the journey is equally unsettling. Because if our reality is just one possible structure, one consistent solution among infinite others, then maybe our universe isn't infinite at all. Maybe it's finite, fragile, and floating in a void of true nothingness. And if that's the case, then the scariest truth isn't that everything is numbers, but that everything might end. For so long, humanity has imagined the universe as endless, stretching forever in all directions, a vast ocean of stars with no edge and no end. Infinity feels safe in a strange way because it allows us to believe that there will always be more, that no matter how far you go, there is still something beyond. But what if that belief is wrong? What if the universe is not infinite but finite? A cosmic bubble floating in an even darker, emptier void? That possibility has haunted scientists and philosophers alike, because if the universe is a bubble, then it means there could be an edge, a boundary, and perhaps even an outside, something far more unsettling than we are prepared to face. The concept of a finite universe comes from multiple lines of reasoning. First, the observable universe is already finite. We can only see as far as light has had time to travel since the Big Bang, about 13.8 billion years. Beyond that horizon, the light hasn't reached us yet, which means our visible cosmos is a sphere with a radius of roughly 46 billion light-years. That doesn't necessarily mean the universe stops there, but it reminds us that our view is limited. And just because something feels endless from the inside doesn't mean it actually is. Imagine standing in the middle of an ocean. No matter where you look, the water seems to stretch forever, but eventually there is land, a shoreline, and the illusion of infinity breaks. Could the universe be the same? Cosmic background radiation, the afterglow of the Big Bang, adds to this idea. Its pattern suggests the universe is nearly flat, but not perfectly. A slight curvature could mean that space loops back on itself, like the surface of a balloon. On the balloon's surface you can travel forever without hitting an edge, yet the balloon itself is finite. If our universe works the same way, then infinity is just an illusion. We may live in a grand but closed bubble, where every path eventually curves back around, where travelling far enough could, in theory, bring you back to where you started. This raises chilling questions. If the universe is a bubble, what lies beyond the bubble's edge? The most unnerving possibility is nothing. True nothingness, not empty space, not dark matter, but the absence of existence itself. Space-time would end at the boundary, and beyond it there would be no beyond. Our minds struggle to process this because we are wired to imagine something. But in physics, nothingness is a valid concept, a void without dimensions, without time, without potential. To think that our entire universe could be floating inside a shell of nothingness is terrifying, because it reminds us how fragile our existence really is. Everything we know, all of history, life, galaxies, energy, confined inside a single bubble that could, in theory, burst. And the bubble theory doesn't stop at just one. Inflationary cosmology, which describes how the universe expanded explosively in its first moments, suggests that multiple bubbles could form in the fabric of reality. Each bubble could be its own universe, with its own physics, floating in an infinite cosmic foam. If that's true, our universe isn't unique. It's just one bubble among countless others. Some might be vast, others tiny. Some could collapse in an instant. Others could expand forever. But every bubble would be finite, and every bubble would eventually pop. Our universe might seem stable, but physics reminds us that everything has an expiration date. Stars die, galaxies collide, and even the cosmos itself could decay into nothing. For those who fear the idea of infinity, the bubble model is comforting. It places boundaries on the chaos. But for those who crave stability, it's a nightmare. A finite universe is fragile. It can be measured, contained, and destroyed. If the universe is infinite, then at least there is no end in sight. But if it is finite, then every second we exist is balanced on the edge of oblivion. And what if the bubble bursts? Some theories suggest that the vacuum of space is not stable, that a more fundamental true vacuum could exist. If a bubble of this vacuum formed, it would expand at the speed of light, erasing our universe instantly. We would never see it coming. One moment we exist, and the next we're gone. This might sound like science fiction, but it's grounded in real physics. The Higgs field, which gives particles their mass, might not be perfectly stable. If it isn't, then our universe is living on borrowed time. The comforting illusion of permanence could be shattered in an instant. And because the bubble would expand faster than light, no warning would save us. The scariest truth isn't that the universe is finite, it's that it might be temporary. Of course, the idea of a bubble universe also opens the door to strange possibilities. If space curves back on itself, then the cosmos might be finite but unbounded. That means you could travel forever without finding an edge, looping endlessly through the same cosmic terrain. This is a mind-bending thought because it suggests we could be seeing the same galaxies from multiple directions, light wrapping around the universe and reaching us in strange ways. What if the night sky is showing us illusions of repetition, echoes of the same objects seen over and over again? It makes you wonder whether we've mistaken infinity for a cosmic hall of mirrors. The bubble universe also forces us to reconsider our place in reality. If there are countless bubbles, each with different laws of physics, then ours might just be one lucky accident where conditions allow life to form. In most bubbles, stars might never ignite, atoms might never bond, and existence might be sterile and dark. But here, in our finite bubble, the equations lined up perfectly to produce galaxies, planets, and eventually us. This idea is unsettling because it suggests we're not inevitable, we're improbable. Our universe is not the rule but the exception, a fragile coincidence floating in an endless void of failed bubbles. But perhaps the scariest implication of all is that even if the universe is finite, our minds cannot escape imagining infinity. Boundaries force us to ask, what's outside? And even if the answer is nothing, the question gnaws at us. We crave meaning, expansion, and possibility. But a finite universe denies us that comfort. Instead, it reminds us that existence is delicate, constrained, and temporary. It forces us to confront the fragility of everything we hold dear. And yet, in that fragility, there is also urgency. If the universe is finite and fleeting, then every moment we have matters more. Every star, every life, every choice is carved against the backdrop of impermanence, and perhaps that is what makes it meaningful. As we leave the bubble behind, the next idea takes us into even darker territory. Because if our universe is a bubble floating in nothingness, then maybe it isn't even real at all. Maybe everything we see and experience is not physical but simulated, a construct running inside something else. And if that's true, then the scariest truth about the universe isn't its fragility, its finiteness, or even its end. It's that it might never have existed in the first place. What if everything you've ever seen, every sound you've ever heard, every feeling you've ever had wasn't happening in the real world at all? What if reality itself, the stars, the ground beneath your feet, even your own body, was nothing more than a carefully crafted illusion running inside a vast computational system? This is the simulation hypothesis, one of the most controversial and unsettling ideas of our time, and it forces us to question the very fabric of existence. To many, it sounds like a plot ripped straight from a science fiction movie, but some of the greatest minds in technology and physics have taken it seriously, raising the possibility that our universe is less like a physical place and more like a program, And if that's true, then we aren't just living in a bubble, we're living inside someone's code. The concept gained mainstream attention thanks to philosopher Nick Bostrom, who argued that if any advanced civilization gains the ability to simulate entire universes with conscious beings inside, then one of three things must be true. Either civilizations never reach that level of technology, they choose not to run simulations, or we're almost certainly living in one. Think about it. If simulations are possible, then they could be run in staggering numbers. For every one real universe, there could be millions of simulated ones. That means statistically, the odds of us being in the base reality are slim to none. The unsettling conclusion is that everything we experience, the sun rising, the passing of years, even our memories, could be data processed in a system we'll never see. The evidence, while circumstantial, is thought-provoking. Scientists point to the strange digital-like qualities of our universe. Space and time, once believed to be continuous, now appear quantized at the smallest scales, broken into discrete units like pixels on a screen. The limits imposed by the speed of light feel suspiciously like a processing cap, a maximum speed set by the system. Quantum mechanics, with its probabilities and randomness, resembles the rendering tricks used in video games, where details only load when you look at them, conserving resources. Could it be that reality behaves strangely, not because it is mysterious, but because it is simulated? Even our mathematics hint at the possibility. Some researchers have discovered what looks like error-correcting codes hidden in the equations of string theory, the kind of codes engineers use to ensure data integrity in computers. If the laws of physics contain code, then maybe the universe is less like a natural phenomenon and more like a program running on a cosmic computer. This isn't to say there's a keyboard somewhere with our world running on it, but rather that reality itself could be information, bits instead of atoms, logic instead of matter. And if that's true, then the rules we take for granted are not laws of nature but design choices. The most disturbing part of the simulation idea isn't the possibility that we're living in a digital construct, but what it implies about whoever or whatever is running it. Are we part of an experiment? Entertainment? A historical recreation? If the simulation hypothesis is true, then someone, somewhere, decided to run us, and that means our entire existence could be serving a purpose we'll never understand. Worse still, there is no guarantee that the simulation will continue forever. Just as we shut down games, programs, and experiments when they've served their purpose, our reality could be switched off in an instant. To us, it would look like the end of the world, but to whoever controls it, it would be nothing more than pressing a button. This raises a chilling thought. How much control do we really have? If our world is simulated, then free will itself might be an illusion. Our choices could be nothing more than lines of code executing according to pre-programmed conditions. We may feel like autonomous beings, but in truth, we might be following scripts, unaware of the invisible parameters that define us. Of course, this doesn't diminish our experience. We feel, think, and exist regardless. But it does redefine what existence means. If everything is code, then our lives are computations, our emotions are data, and our deaths are deletions. And yet, there's another side to this argument that's just as haunting. Some argue that even if we are in a simulation, it doesn't matter. Reality is defined by perception, and if we perceive it as real, then it is real to us. The pain we feel is real. The love we experience is real. Whether it's atoms or bits, the effect is the same, but for others the idea is intolerable, because if we are simulated, then our universe is not fundamental, and everything we hold sacred is conditional, existing only as long as someone allows it. That is a terrifying lack of permanence. The hypothesis also invites speculation about glitches, moments where the simulation breaks down. People point to déjà vu, unexplained phenomena, or even odd coincidences as possible errors in the code. While science doesn't endorse such claims, the allure of thinking we've spotted the cracks in reality is irresistible. After all, in every program there are bugs. If ours is no different, then maybe the strange, unexplainable parts of our world are the equivalent of seeing behind the curtain. But here's the darkest possibility. What if we're not the first simulation? What if we're part of a chain, with simulated beings creating their own simulations, which in turn create others, on and on into infinity? If that's true, then reality itself becomes impossible to locate. The real world, the original base, may be forever inaccessible. We would be copies of copies stacked endlessly, each one convinced of its own authenticity, but none able to prove it. In that kind of universe, truth itself is slippery. The question, what is real, might not even have an answer. And so, the simulation hypothesis doesn't just challenge physics, it challenges meaning. If we are simulated, what does purpose look like? Do we matter to whoever is running us? Are we simply a passing curiosity or something more? The scariest thought isn't that we're being watched, it's that we aren't. Maybe the system is automated, running without oversight, and our lives are unfolding without anyone caring to notice. That would make us utterly alone, our struggles meaningless beyond the walls of our own coded bubble. As frightening as all of this is, the hypothesis does something extraordinary. It forces us to rethink reality. Whether or not it's true, it makes us ask questions we would otherwise avoid. What does it mean to exist? What does it mean to matter? And how would we live differently if we knew everything around us was nothing more than data? Perhaps the most unsettling part of the simulation hypothesis is that it's not easily dismissed. Technology is advancing. We're already building virtual worlds with increasing realism. Who's to say that in the far future, civilizations won't create universes like ours? And if they will, then the odds suggest they already have. As this thought lingers, we're left with a disturbing possibility. The scariest truth about the universe might not be that it's finite, fragile, or doomed, but that it never truly existed at all. It could all be a mirage, a program, a story written in code, and yet, even if that's the case, we are living it. And until someone presses stop, it is the only reality we'll ever know. Every story has an ending, and as much as we may not want to think about it, the universe is no exception. From the moment of the Big Bang, when everything we know burst into existence from an unimaginable point of energy, the cosmos has been in motion, expanding, cooling, and evolving. But expansion and evolution are not endless. They come with consequences, and those consequences lead us down a dark road to the inevitable fate of everything. When scientists talk about the ultimate end of the universe, they often describe it in terms of entropy, the natural tendency of systems to move from order to disorder. And if there's one thing that terrifies both scientists and philosophers alike, it's this: entropy always wins. Right now, the universe is vibrant. Stars are burning, galaxies are spinning. Life is flourishing in at least one tiny corner of it. But all of this activity comes at a cost. Stars shine by burning fuel, galaxies form because gravity holds them together, and life survives by consuming energy. Each of these processes increases entropy, slowly chipping away at the universe's supply of usable energy. And here's the grim truth. Once that energy is gone, it cannot be replenished. The universe is like a grand machine winding down, and eventually it will run out of fuel. This leads to what scientists call the heat death of the universe, one of the most chilling scenarios imaginable. In this future, the stars exhaust their fuel and go dark. New stars stop forming. Galaxies grow dim as black holes consume whatever remains. Over trillions upon trillions of years, even the black holes evaporate through Hawking radiation, releasing their mass as faint particles. What's left is not a cosmos filled with wonder, but a thin, cold mist of particles spread so far apart that they rarely, if ever, interact. Motion ceases. Heat ceases. The universe becomes a silent, frozen void where nothing happens, because nothing can happen. Time itself loses meaning, because without change, there is no way to measure it. If the idea of heat death wasn't terrifying enough, there are other scenarios that are equally bleak. One is the Big Crunch. In this version of the future, the expansion of the universe eventually slows and reverses. Galaxies stop racing away from each other and begin to collapse back inward, pulled together by gravity. Over unimaginable eons, the universe shrinks, heating up as matter compresses. Stars and galaxies fall back into one another until finally everything collapses into a single, dense point, not unlike the Big Bang in reverse. Some speculate this could trigger another Big Bang, leading to a cyclic universe that lives, dies, and is reborn endlessly. But even if that's true, the thought of our universe collapsing into oblivion is no less unsettling. Then there's the Big Rip. Unlike the Crunch, which brings everything back together, the rip pulls everything apart. If dark energy, the mysterious force causing the universe's expansion to accelerate, grows stronger over time, it could eventually tear galaxies apart, then stars, then planets, and finally atoms themselves. The very fabric of space-time would rip apart, leaving nothing but fragments of energy scattered in the void. It's a future so violent and final that it makes even heat death seem merciful. What makes all of these scenarios so haunting is that they don't just describe the end of stars or galaxies, they describe the end of possibility itself. No new worlds to discover, no new stories to unfold, no second chances, just silence. And while these futures may be trillions or even quadrillions of years away, the inevitability of them forces us to confront the fragility of existence right now. It reminds us that even the universe has a timer running down, and eventually it too will expire. But entropy doesn't just apply to the distant future, it affects us every day. The same principle that leads to the heat death of the cosmos is the one that makes your coffee cool, your body age, and your memories fade. We are all microcosms of the universe, winding down bit by bit. Just as stars burn out, so do we. In that sense, the end of the universe isn't just a distant concept, it's a reflection of our own mortality. And perhaps that's why it's so unsettling. We see in the cosmos the same fate that awaits us: dissolution, silence, and nothingness. Yet there's another layer of fear that creeps in when we think about the universe's end. What if it comes sooner than we expect? Some scientists warn of vacuum decay, a catastrophic event that could occur at any moment. If the Higgs field that underpins particle physics isn't truly stable, then it could suddenly collapse to a lower energy state. If that happened, a bubble of this true vacuum would form and expand at the speed of light, erasing everything in its path. Planets, stars, galaxies, all gone in an instant. There would be no warning, no escape, no survivors. One second we exist, the next we don't. It's a cosmic guillotine hanging over us, silent and unseen. When you stack all of these possibilities together, the picture is bleak. Whether by heat, death, crunch, rip, or vacuum decay, the universe seems destined to end in silence. And yet, in that silence lies the ultimate perspective. If the cosmos itself is temporary, then permanence is an illusion. The only reality we have is the present, the brief window where stars still shine, galaxies still form, and life still thinks and dreams. That's why some philosophers argue that contemplating the universe's death isn't about despair, but about urgency. It reminds us to live fully, to cherish the fleeting miracle of existence while it lasts. Because compared to the infinite lifeless void that may come, our moment here is extraordinary. And there's one more thought that makes all of this even more unnerving. If the universe is heading toward an end, what happens to us? Not just our bodies, but our minds, our consciousness. Do we fade with the stars, erased without a trace? Or is there something beyond the collapse, something hidden that physics hasn't yet revealed? Could new laws of nature appear when the old ones break down? Could consciousness persist even when matter dissolves? These are questions science cannot yet answer, but they hover like shadows at the edge of our understanding. So when we talk about the scariest truth of the universe, entropy is at the heart of it. It's not just the end of things, it's the end of meaning, the end of change, the end of story. And whether it arrives in a trillion years or a moment from now, the fact that it looms is enough to remind us of our place. We are fragile beings in a fragile cosmos, living in the brief flash between a fiery beginning and a cold, silent end. That knowledge is terrifying, but it is also clarifying. It strips away illusions of permanence and leaves us with the raw truth. Everything ends. And perhaps, just perhaps, that is what makes the time we have so valuable. Time is something we take for granted, a constant companion ticking in the background of our lives. But what if time itself isn't real in the way we think it is? What if the seconds on your clock, the years on the calendar, and even the sense of yesterday and tomorrow are illusions created by our minds or by the structure of the universe itself? This question cuts to the heart of some of the deepest mysteries in physics and philosophy, and the more we investigate, the more unsettling the answers become. Because if time is not what it appears to be, then everything we think we know about reality cause, effect, history and future, begins to unravel. The common view of time is simple. It flows like a river. The past is behind us, the future lies ahead, and the present is the moment we occupy. But physics paints a stranger picture. According to Einstein's theory of relativity, time is not a universal constant, it's relative. The faster you move, the slower time passes for you compared to someone standing still. Gravity bends not just space but time itself, stretching or compressing its flow depending on where you are. This means there is no single now that applies to everyone. Two observers in different places may disagree about the order of events, and both would be correct. Already this shatters the comfortable illusion of time as something absolute and uniform. But relativity is just the beginning. In the realm of quantum mechanics, time becomes even more elusive. Some interpretations suggest that time might not exist at the deepest level of reality at all. Instead, what we perceive as time could emerge from the entanglement and interactions of particles, a kind of illusion that arises only when systems grow large enough. If this is true, then time is not fundamental. It's a construct, a way of organizing reality that doesn't exist in the raw equations of the universe. In other words, the ticking clock might be no more real than the ticking of a metronome in a song. It feels essential, but it's just a rhythm imposed on something deeper. This idea is reinforced by the block universe theory, one of the most chilling models of reality. According to this view, the past, present, and future all exist simultaneously in a four-dimensional structure. Time doesn't flow. Instead, it's already laid out, like a map. Every moment of your life, your birth, your experiences, even your death, exists at once, carved into the fabric of space-time. We only experience time as flowing because our consciousness moves along the timeline like a spotlight scanning across the page. If this is true, then free will may be an illusion, because the future is already fixed, just as the past is. We are not writing our story as we go. We are simply reading it, line by line, unaware that the ending has already been written. This raises disturbing questions about what it means to live. If every moment is eternal, then nothing is ever truly lost. But nothing is ever truly new either. The joy you feel now already exists forever, but so does the pain you'll feel tomorrow. Does this make life more meaningful, knowing that it's eternal in some sense? Or does it make it meaningless, knowing that it's fixed and unchangeable? The block universe forces us to confront whether our choices are real or merely the illusion of choice, a story playing out in a script we can't rewrite. Then there are the paradoxes of time. If time is real, can it be manipulated? Could we ever travel backward, rewriting history or meeting ourselves in the past? Science fiction is filled with time travel tales, but physics offers grim warnings. Travelling into the past could create paradoxes, like the famous grandfather paradox, where going back to stop your grandfather from meeting your grandmother would erase your own existence. Some theories get around this by suggesting multiple timelines. If you change the past, you don't alter your own history but create a new one, branching off from the original. This would mean infinite versions of reality, each shaped by different choices, each unfolding in parallel. But if that's the case, then our universe may not be unique. It may be just one of countless timelines stretching endlessly in every direction. Even more unsettling is the idea that time might not move forward at all. Some physicists argue that the laws of physics don't require time to have a direction. The arrow of time, the sense that it flows from past to future, might just be a side effect of entropy increasing. In a universe with low entropy, events could flow backward as easily as forward. Imagine experiencing your life in reverse, starting from death and moving back toward birth, with all events replaying in opposite order. To us this feels absurd, but to the laws of physics it makes no difference. Time has no preferred direction. It's only our perception, shaped by entropy, that gives it one. And what about the possibility that time is entirely a product of consciousness? Some philosophers argue that without an observer, time has no meaning. The universe could be a static structure of possibilities, and our minds impose the illusion of flow to make sense of it. This would mean that time isn't a property of the cosmos, it's a property of us. Without minds to perceive it, there is no past, no present, no future, only existence. But that brings us to a frightening question. If time is in our minds, what happens when our minds are gone? Does time end with us? If all of this seems abstract, consider how it changes your life. If the future already exists, then everything you will ever do is already there. The choices you agonize over have already been made. If time is an illusion, then your entire life could be a single frozen structure, experienced moment by moment but never changing. And if time is only a construct of consciousness, then when you close your eyes for the last time, not only does your story end, so does time itself. At least for you. These ideas force us to rethink the simplest, most taken for granted part of reality, turning something as ordinary as the ticking of a clock into one of the greatest mysteries of all. And yet, there's something even darker hidden in the nature of time. If time is an illusion, then so is progress. The universe is not moving toward anything. It's already complete. The future isn't something we can change. It's something we're already living out. That realization can be paralyzing because it suggests that effort, struggle, and even hope are just illusions layered onto a static reality. But it can also be liberating. If the future is fixed, then fear loses its power. What will happen has already happened, and worrying cannot alter it. In that sense, time's greatest trick may be convincing us that we have more control than we really do. As we peel back these layers, the scariest truth emerges. Time may not be the flowing river we believe it to be. It may be a frozen landscape, a construct of consciousness, or an illusion spun by entropy. And if that's the case, then our entire understanding of existence is incomplete. Because what is life, if not lived in time? What is meaning, if not tied to past, present, and future? If time is an illusion, then so too might be everything we attach to it, our stories, our choices, our very identities. And that is perhaps the most unsettling possibility of all, that we are shadows moving through a reality where nothing truly changes, and the clock we hear ticking is not counting down to an end, but reminding us of the illusion we cannot escape. For all the vastness of the cosmos, for all the galaxies and black holes and swirling nebulae, the most puzzling phenomenon might not lie out there in the stars, but right here within us. Consciousness. The universe could stretch for billions of light years in every direction, yet without consciousness to observe it. Would any of it matter? Would the stars exist in any meaningful sense if there was no mind to see their light? This question has haunted thinkers for centuries, and modern science hasn't solved it. It has only made it more unsettling. Because the more we explore, the more it seems that consciousness may not be a byproduct of the universe at all, but something fundamental, woven into the very fabric of reality. And if that's true, then the scariest truth of the universe might not be its size or its fate, but the fact that we cannot separate the cosmos from the observer. On the surface, it feels simple. Consciousness arises from the brain. Billions of neurons fire in intricate patterns, creating thoughts, emotions, and awareness. But dig deeper, and the picture falls apart. How does physical matter, electrical impulses and chemical reactions, create the rich subjective experience of being alive? How does a cluster of neurons give rise to the feeling of joy, the ache of loss, the awe of looking at a night sky? This is the hard problem of consciousness, and no theory has truly cracked it. Some scientists argue that consciousness might emerge when information is processed in a certain way, as if awareness is the result of complexity. Others suggest it might be a property of matter itself, existing in some primitive form even in the tiniest particles, like a flicker of awareness in every atom that scales up to human experience. If that's true, then consciousness isn't just in us, it's in everything. This idea, called panpsychism, is both fascinating and terrifying. It suggests that the universe is not a cold, lifeless machine, but a sea of awareness, with every particle carrying some trace of subjectivity. A rock, a tree, even the air might hold fragments of proto-consciousness. While we experience awareness in a unified way, reality could be teeming with tiny sparks of perception, too small for us to notice. In this view, consciousness is not rare, it's universal, and if that's the case, then maybe the universe itself is conscious in some way, experiencing its own existence across scales we can't begin to imagine. Quantum mechanics only deepens the mystery. At the smallest scales, particles don't behave like solid objects, but as waves of probability, existing in multiple states at once until they are measured. The act of observation collapses those probabilities into a definite outcome. This has led some to speculate that consciousness plays a fundamental role in shaping reality, that without an observer, the universe exists only as potential. In other words, reality might not exist independently of the mind. The mind might be necessary to bring it into being. If that's true, then the universe isn't just out there. It's co-created with us, drawn into existence every moment by consciousness itself. But if consciousness is so central, then where does it come from and where does it go? When we die, does our awareness vanish with the brain, or does it continue in some other form? If consciousness is fundamental, like space and time, then maybe it doesn't disappear at all. Maybe it shifts, changes, or re-enters the vast sea of awareness that underlies the universe. This possibility is both comforting and unnerving. It suggests we are more than our bodies, but it also implies that our individuality might not survive, that what we call us could dissolve into something much larger and more impersonal. And yet, there's another dimension to this mystery. If consciousness shapes reality, then how much of what we see is truly out there, and how much is constructed by our minds? Our senses give us the impression of a solid, stable world, but neuroscience shows us that perception is a model, a simulation created by the brain. We don't see reality. We see our brain's best guess at reality, built from fragments of light and sound filtered through experience. Colours don't exist outside of us. They are interpretations of wavelengths. Sounds don't exist outside of us. They are vibrations translated into meaning. Even time and space might be mental constructs, ways our brains organise information into something we can navigate. If that's the case, then the world we experience is less like reality and more like a virtual interface, hiding the true complexity of the universe behind a simplified model. This raises disturbing questions about what lies beyond perception. If the reality we see is a simulation of sorts, then the actual universe could be utterly different from what we think. We might be living inside a carefully filtered version of reality, one designed not to show us truth, but to keep us alive. In that sense, we are prisoners of our own consciousness, confined to the reality it generates, and we may never escape it. But perhaps the most haunting possibility is that consciousness is not only fundamental but inescapable. Imagine a universe where awareness persists no matter what, where death is not an end but a transition, where consciousness cannot be destroyed because it is not material. Such a universe would mean that we never truly stop experiencing. There would always be a next moment, even if it isn't in this world. To some, this is comforting, the idea of an eternal awareness. But to others, it is terrifying. The thought of never being able to escape, of existence stretching endlessly, of being unable to fade into nothingness. An eternal consciousness could be heaven or hell depending on what it encounters, and that uncertainty is what makes it so chilling. And if consciousness is eternal, then maybe the universe itself is conscious too. Some theorists have speculated that the cosmos could be a kind of vast brain, with galaxies and filaments of matter functioning like neurons. Our awareness might be a fragment of a greater cosmic mind, like a single thought in the vastness of an infinite intelligence. If this is true, then we are not separate from the universe. We are the universe, experiencing itself through countless perspectives. The stars we look at are not distant objects but parts of the same mind reflecting back at us. It's a beautiful idea, but it also strips away individuality, reminding us that we may not exist as separate entities at all. So when we ask about consciousness, we are really asking about the nature of reality itself. Is awareness a byproduct of matter, or is matter a byproduct of awareness? Does the universe give rise to consciousness, or does consciousness give rise to the universe? These are not just philosophical puzzles, they are questions that cut to the core of existence. Because if consciousness is fundamental, then everything we know is shaped by it, and everything we believe about the external world may be secondary to the internal experience of awareness. And that might be the scariest truth of all, that we cannot separate ourselves from the universe because we are not simply in it, we are it. Consciousness is the thread that ties everything together, the mystery we cannot escape, the one thing that remains when all else fades. And if we ever do uncover the ultimate truth of reality, it may not be out there in the stars, but in the awareness that is asking the question in the first place. If the universe already feels incomprehensibly vast in 3 dimensions, imagine for a moment that what we see is only the surface of something much greater. For centuries, humans have thought of space as a stage stretching in 3 directions: length, width, and height, anchored by the steady ticking of time. But what if this 4-dimensional framework isn't the whole story? What if hidden layers of existence stretch beyond our perception, dimensions we cannot see, but which may define the very structure of reality itself? The idea of higher dimensions is not just science fiction speculation. It is at the core of some of the most serious scientific theories about the universe. And if those theories are true, then the universe is far stranger and more unsettling than we ever dared to imagine. To understand this, think of a flat drawing on a piece of paper. That 2-dimensional world has length and width, but no depth. If a 3-dimensional creature reached into that paper world, the flat beings inside would see only slices of its body. They could never comprehend the full form because they'd be trapped in their limited perspective. Now flip that idea back onto us. We live in 3 dimensions, but if higher dimensions exist, we may only see slices of them, shadows of a larger reality that our senses are too limited to grasp. The unsettling truth is that our universe could be part of a higher dimensional structure, like a flat page in a book of infinite thickness. One of the most striking scientific frameworks that relies on higher dimensions is string theory. Instead of describing the universe as made up of point-like particles, string theory imagines that everything is built from tiny vibrating strings. But here's the catch. For the math to work, the universe needs extra dimensions, far more than the 4 we experience. Some versions suggest 10, 11, or even 26 dimensions, curled up so tightly that we cannot perceive them. These hidden dimensions could explain why the laws of physics appear so finely tuned for life, why gravity behaves so strangely, and why the cosmos is structured the way it is. But if they are real, then the universe we see is only a fraction of what exists, like peering at the tip of an iceberg while the rest stretches invisibly beneath the surface. And what lies hidden in those dimensions? Some theorists suggest they could be the key to parallel universes. Just as different pages of a book can exist side by side without touching, entire universes could be stacked along higher dimensions, each following its own rules and unfolding its own histories. In one, the stars might burn blue instead of yellow. In another, life may have evolved along entirely different paths. In yet another, you might exist but living a completely different life, made possible not by speculation, but by the structure of space-time itself. The higher dimensional fabric could be the scaffolding that holds infinite realities together. This isn't only speculation from theoretical physicists, it is hinted at by cosmic mysteries we can't yet explain. Take dark matter and dark energy, which together make up about 95% of the universe. They don't emit light, don't interact with ordinary matter in the usual way, and yet they shape galaxies, drive the expansion of the cosmos, and dominate the universe's destiny. If dark matter and dark energy are not substances we can detect, could they instead be the gravitational pull or influence of higher dimensions bleeding into our own? In that sense, the cosmos is not just filled with invisible matter, but with the fingerprints of hidden layers of reality pressing against us from outside our perception. But there's a darker implication too. If there are higher dimensions, then the universe may not be as stable as we think. Imagine space-time as a sheet stretched out across a frame. Our 3-dimensional world clings to that sheet. But if higher dimensional forces tug at it, everything we know could shift, twist, or collapse into something unimaginable. The universe could one day tunnel into another dimensional state, changing its laws of physics in an instant. What we take for granted, light, matter, life itself, could vanish if higher dimensions shift in ways beyond our control. This isn't just theory. It's a possibility embedded in the math of physics, and though it may never happen in our lifetime, it underscores how fragile our reality might be when viewed against the backdrop of dimensions we cannot perceive. Even time itself may be just one dimension in a larger structure. To us, time moves forward, a relentless arrow dragging us from past to future. But from a higher dimensional perspective, time might not flow at all. It might be laid out like a landscape, where past, present, and future coexist. We experience it sequentially only because our consciousness moves through it in one direction. But if higher beings, or higher realities exist, they might see all of time at once, just as we see an entire landscape from above rather than trudging step by step across it. To them, the rise and fall of civilizations, the birth and death of stars, even the fate of the universe could be visible all at once, a single tapestry rather than a linear story. That perspective strips away the illusion of control we feel, reminding us that our experience of time might be just another trick of perception. And yet, as unsettling as it sounds, there's also a possibility that higher dimensions are the reason we exist at all. The laws of physics appear balanced on a razor's edge. If gravity were a little stronger, stars would collapse too quickly. If it were weaker, galaxies would never form. If the forces of nature were even slightly different, life as we know it could not exist. Could higher dimensions explain this uncanny fine-tuning? Maybe our universe is just one of many, its laws set not by chance, but by the structure of higher dimensional reality. We live here not because the universe is special, but because in the vast multiverse of possibilities, this one happens to allow beings like us to ask the question. Still, the thought lingers. What if higher dimensions are not just theoretical, but real, present all around us, shaping our reality in ways we cannot see? If they are, then everything we know, space, time, existence, becomes far less certain. We are like ants crawling on a sheet of paper, blind to the vast space above and below, convinced our flat world is all there is. But one day, if science pierces through, we might glimpse the greater reality beyond, and the truth could be far stranger and more frightening than we ever imagined. Because the universe we see may not be the universe at all. It may be nothing more than a shadow cast by dimensions we cannot perceive. When people look up at the night sky, most see stars shimmering like tiny candles across the darkness. It feels eternal, almost comforting, as though the cosmos is a constant backdrop that will always be there. But the truth is far darker. Everything you see when you stare at the heavens, the stars, the galaxies, the planets, comes with an expiration date. The universe itself is not infinite in its vitality. It is not a stage that will shine forever. Its fate has already been set in motion, and what science reveals about the ultimate end of the cosmos is both terrifying and humbling. Let's begin with what we know. Stars live on borrowed time. Our own sun, for all its brilliance, is halfway through its life cycle. In about 5 billion years, it will swell into a red giant engulfing Mercury, Venus, and possibly Earth, before collapsing into a white dwarf that will slowly fade into darkness. Now multiply that fate across every star in the universe. Each one, no matter how massive or powerful, will eventually exhaust its fuel and go out. Galaxies will dim, star formation will stop, and the cosmos will begin sliding into what physicists call the stellar era's end. But the most unsettling part is not that stars will die, it's that nothing can stop it. The laws of thermodynamics ensure that energy always spreads out, and over time, everything burns itself out. After the last star dies, black holes will dominate the universe. They will be the final rulers of the cosmos, swallowing matter, light, and even each other. The Milky Way's black hole may merge with Andromeda's after the galaxies collide billions of years from now, forming a supermassive monster at the center of the new galaxy. Across the universe, collisions like this will happen again and again until only black holes remain. But even they are not eternal. Thanks to Hawking radiation, they will slowly evaporate, leaking energy back into space until they vanish completely. It will take unimaginable timescales, trillions upon trillions of years, but eventually, the last black hole will evaporate, leaving nothing but a universe filled with cold, thin radiation. This is what scientists call the heat death, or big freeze. Imagine a cosmos where no stars shine, no planets orbit, no black holes remain. Only particles drifting in endless darkness, too spread out to ever collide or form anything new. No motion, no heat, no activity. Time loses meaning because nothing changes. This is the most widely accepted scenario for the end of the universe, and it is one of the most chilling thoughts humanity has ever confronted. Not just because it means everything will end, but because it means everything will end in silence. But heat death is not the only possibility. There are other theories, and some are even more terrifying. Consider the Big Rip. The universe is expanding, and thanks to dark energy, that expansion is accelerating. Galaxies are moving away from each other faster and faster. If this acceleration continues unchecked, there could come a time when galaxies are ripped apart, then stars, then planets, and finally atoms themselves. Space-time would stretch so violently that the very building blocks of reality would disintegrate. It's called the Big Rip because nothing survives, not even the fabric of the universe. In this vision of the future, destruction comes not slowly and quietly, but violently and utterly, tearing everything to pieces. Then there's the Big Crunch, the mirror opposite of the rip. If dark energy weakens over time, gravity could eventually take over. Instead of racing outward, the universe would slow, then collapse back in on itself. Galaxies would collide, stars would smash together, and everything would compress into an incredibly hot, dense point. In some theories, this collapse could spark another Big Bang, creating a new universe. That would mean the cosmos is cyclical, endlessly dying and being reborn. But even if that's true, the fact remains. Our universe, the one we inhabit, would end in a catastrophic collapse. And if those possibilities weren't unnerving enough, there is one more scenario that scientists warn could happen without warning. Vacuum decay. This is the idea that the universe we live in may not be in its most stable state. Instead, it may be a false vacuum, a delicate bubble of stability that could collapse at any moment. If that collapse began, it would expand at the speed of light, rewriting the laws of physics as it swept across the cosmos. Galaxies, planets, life, everything would be destroyed instantly. No warning, no escape. One moment we exist, the next we don't. It is one of the most horrifying possibilities because it is both sudden and unstoppable. Each of these scenarios paints a grim picture, but what makes them even more unsettling is how inevitable they feel. We're used to thinking of endings as something avoidable, something we can fight or prevent. But the end of the universe is written into the fabric of physics itself. Whether it's heat death, rip, crunch, or vacuum decay, the universe is on a path to destruction. It's not a matter of if, but when. And yet this knowledge also reframes everything about our existence. If the universe itself is temporary, then the stars above us are even more miraculous. They are not permanent fixtures, but fleeting lights burning in the darkness of inevitability. The same goes for life. Against the vast indifference of the cosmos, the fact that we are here at all, thinking, feeling, creating, becomes extraordinary. We are a brief flare of awareness in a universe destined for silence, and that awareness is the rarest thing of all. Some scientists and philosophers argue that contemplating the end of the universe is not about despair but perspective. If everything is temporary, then our moment matters more, not less. It pushes us to find meaning in the now, to value the fragile and fleeting beauty of existence, rather than waiting for permanence that will never come. The scariest truth about the universe isn't just that it will end, it's that everything ends, and that truth forces us to confront what we choose to do with the time we have. So when you look at the stars tonight, remember that you're seeing a moment frozen in time, a moment that will one day vanish. The galaxies shining from billions of light years away will not last forever, but right now they blaze with unimaginable beauty. That beauty exists because the universe is still alive, still burning against the tide of entropy. And while we may not be able to change the fate of the cosmos, we can cherish the miracle of being here in this fleeting window where existence shines before the final silence. If the universe is heading toward an inevitable end, one question rises above all others: can we escape it? For centuries humans have stared into the abyss of mortality, both personal and cosmic, and wondered if there is a way out. Individually, we cling to myths of afterlives or reincarnation. Collectively, as a species, we imagine building machines, ships, or even whole civilizations capable of transcending the decay written into the stars. But when we measure those dreams against the hard truths of physics, the answers become complicated and often disturbing. What does survival look like when the very fabric of space-time is collapsing around us? Can we truly outrun the fate of the universe, or are we bound to vanish with it? One of the most popular ideas is that humanity could escape into the multiverse. If our universe is just one of many, each existing in higher dimensions or separated by bubbles of space-time, then perhaps it is possible to slip from one to another. The concept is intoxicating. When this cosmos grows cold and lifeless, maybe there's another fresh universe waiting for us, one where the stars are still young. Some theories even suggest that black holes could be gateways to other universes, their singularities leading not to destruction but to new big bangs in hidden dimensions. If that's true, then travelling into a black hole might not be a death sentence. It might be an escape hatch. But here lies the paradox: we have no way of knowing. Crossing such a threshold could mean survival, or it could mean annihilation. Until science finds a way to test it, the idea of fleeing into another universe remains speculation, a desperate dream of immortality for a species terrified of endings. Another vision of escape lies not in travelling outward, but inward, into simulation. Some scientists and philosophers argue that if consciousness can be uploaded into machines, then perhaps humanity could continue existing long after the physical universe dies. In theory, if we could create a stable digital environment, powered by exotic energy sources or compressed into quantum systems, consciousness might live forever, unaffected by the decay of stars and galaxies. But this raises even darker questions. If we already live in a simulation, a possibility seriously entertained by thinkers today, then perhaps our reality itself is someone else's attempt to cheat entropy. And if that's true, what happens when our simulation is turned off? What if our entire universe is not the real one, but a fragile construct that can be deleted in an instant? Escape through simulation might buy time, but it doesn't guarantee salvation. It may just replace one fragile existence with another, vulnerable to forces outside our understanding. Some propose physical megastructures as the key to survival. Dyson spheres, massive shells built around stars to harvest their energy, could sustain civilizations for eons, but even stars are temporary. Eventually they burn out, and no engineering marvel can reverse entropy. A more radical proposal is the idea of building civilizations that live off black holes, harnessing their Hawking radiation as they slowly evaporate. This could, in theory, stretch existence into the farthest reaches of time, but even that is only a delay, not a solution. When the last black hole vanishes, so too would the last light of civilization. But perhaps the most chilling idea of all is that there is no escape. If entropy is absolute, if the laws of physics cannot be bent or rewritten, then survival beyond the universe is not just difficult, it's impossible. In that case, all dreams of transcendence are illusions, comforting stories we tell ourselves to soften the unbearable truth. If the cosmos itself dies, then so must everything within it. And that means not only our species, but every trace of meaning, every memory, every idea will vanish into silence. Some argue this is the ultimate horror, the total erasure of not just life, but of history itself, as though nothing had ever existed. Yet, in the face of such inevitability, others see liberation. If there is no way out, then the only path is acceptance. Instead of fighting the universe, we can embrace the fleeting miracle of existing within it. Survival becomes less about escaping death and more about finding meaning before it arrives. This perspective echoes through philosophies both ancient and modern. The idea that impermanence makes existence precious, that the very fact we live in a temporary cosmos is what gives life its urgency. If the universe were eternal and unchanging, perhaps existence would lose its intensity. But because it is not, because we know it will end, our moments here blaze brighter against the void. Still, the human mind resists this kind of resignation. We are explorers by nature, unwilling to accept boundaries. The idea that higher dimensions might hold answers keeps scientists probing the edges of physics. Could wormholes, if stabilized, serve as bridges to other realms of spacetime, providing pathways out of a doomed universe? Could exotic forms of matter or energy rewrite the rules of entropy, halting decay in its tracks? Right now, these ideas sit at the edge of science, where theory teeters into speculation. But history has shown that many of today's impossibilities become tomorrow's discoveries. To imagine humanity surrendering without searching every corner of physics for a loophole feels uncharacteristic of who we are. In the end, the question of escape might not be about technology or physics at all, but about perspective. What does it mean to survive? If consciousness could persist in any form, whether uploaded, transdimensional, or embedded in another universe, would that truly count as survival? Or would it be something new, something alien to what we recognize as life. Perhaps the real fear is not death itself, but transformation. The idea that survival may require us to become something unrecognizable, stripped of the humanity that makes us who we are. So can we escape the fate of the universe? The most honest answer is that we don't know. Every path we imagine is riddled with uncertainty, danger, and paradox. Some offer hope, others despair, but none provide certainty. And maybe that uncertainty is what makes the question so powerful. It forces us to confront not only the limits of science, but the limits of ourselves. We are beings caught between the vastness of the cosmos and the inevitability of its end, dreaming of escape even as the clock ticks down. Whether we succeed or fail, the act of dreaming may be the most human thing of all. Because even when faced with the end of everything, we refuse to stop imagining a way out. If the universe itself is fragile, temporary, and destined for an inevitable end, then perhaps the scariest truth is not the mechanics of how it will die, but what that means for us right now. Because behind every scientific theory and every cosmic prediction lies an even deeper question. Does any of it matter? We cling to the idea of purpose, of significance, of meaning woven into the fabric of existence. We write stories, build civilizations, search the skies, all with the hope that our lives are more than temporary flickers in an uncaring void. But when you strip away the comforting illusions, when you stare directly into the abyss, you're left with a chilling thought. What if meaning itself is just an invention, a fragile story we tell ourselves to survive the unbearable truth that the universe does not care? Think about it. Stars burn without intention. Galaxies collide without purpose. Black holes consume everything in their path without malice or mercy. The universe does not explain itself, does not justify itself. It simply exists, driven by blind laws of physics that grind relentlessly forward. We may marvel at its beauty, but beauty is only a human perception. We may see patterns, but patterns are simply our minds imposing order on chaos. And if that's true, then every religion, every philosophy, every dream of destiny is not written into the cosmos but projected onto it by us. We are the authors of meaning, not the discoverers of it. And what terrifies people most is that once you remove the human lens, there may be no meaning at all. Just endless space, endless time, and eventually endless nothing. This realization cuts deeper than death, deeper than entropy, deeper than any physical ending. Because if life has no intrinsic meaning, then even the most brilliant achievements dissolve into irrelevance. The pyramids will crumble, the oceans will dry, Earth itself will burn. Every piece of art, every song, every love story, every memory, all of it will be erased by the same cosmic silence that swallows the stars. And if there is no higher purpose, no ultimate reason behind existence, then all of it, every single thing we do, is temporary theatre performed on a stage destined to collapse. That's the scariest truth of all. Not just that we will die, but that what we do while alive may not matter in any grand cosmic sense. Yet, in this bleak vision, another paradox emerges. If meaning is not given, then it must be created. If the universe does not care, then it is up to us to decide why we should. And perhaps this is what makes life both terrifying and extraordinary. Our existence is a blank canvas, and against the backdrop of a meaningless cosmos, we paint our own purpose. That purpose may not last forever, but in the moment it is real, it is powerful, and it shapes the only reality we know. When someone loves, when someone creates, when someone dares to hope, they carve a pocket of meaning out of the void. It may vanish, but while it lasts, it is everything. Still, the fear lingers. For many, the thought that meaning is temporary makes it feel less real. If it doesn't last forever, if it's destined to fade, is it worth anything at all? This question haunts philosophers and ordinary people alike. Some argue that impermanence intensifies meaning, that a flower is beautiful precisely because it will wilt. Others argue that without eternity everything is futile. The tension between those two ideas, impermanence as beauty, impermanence as futility, sits at the heart of our confrontation with the scariest truth of the universe. There's also the question of consciousness itself. Why does it exist? How did matter give rise to minds capable of asking about meaning in the first place? Some scientists believe consciousness is just an emergent property of complex systems, a byproduct of neurons firing in intricate patterns. Others speculate it is something deeper, woven into the fabric of reality. If consciousness is nothing more than a fluke of biology, then perhaps our search for meaning is just another trick of evolution, a way to keep us motivated to survive. That would mean meaning is not only temporary but artificial, an illusion conjured by brains that refuse to face the void head-on. And if that's true, then the scariest truth is not that there is no meaning, but that our very sense of meaning is a lie. But there's a flip side, and it's just as haunting. What if consciousness is fundamental? What if the universe exists not despite us, but through us? That without observers, reality has no form, no definition? This idea, hinted at in interpretations of quantum mechanics, suggests that our awareness plays a role in shaping the cosmos itself. If that's true, then we are not meaningless at all, we are essential. But that raises its own terrifying question. If consciousness is what gives reality form, then what happens when consciousness is gone? When the last observer fades, does the universe collapse into nothing, not because entropy demanded it, but because no one remains to perceive it? In that sense, the scariest truth might not be that meaning is absent, but that meaning is fragile, dependent on us, and doomed to vanish when we do. Whether meaning is an illusion or a creation, the fact remains, nothing is permanent. And yet, perhaps that is not a curse, but an opportunity. If the universe is indifferent, then we are free to define our own place within it. If nothing lasts forever, then the only time that matters is now. This doesn't erase the fear, it intensifies it, but it also reframes it. We may not be able to conquer death, entropy, or cosmic silence, but we can choose how we live before they arrive. And in a universe where everything ends, choosing to live with courage, with love, with creativity, might be the closest thing to defiance we will ever know. So, when we confront the scariest truth of the universe, it is not simply about black holes, heat death, or cosmic collapse. It is about the realization that we are fragile sparks of awareness, flickering in a storm of indifference. We want permanence, but we are temporary. We want destiny, but we are accidental. We want meaning, but the universe offers none. And yet, in that terrifying emptiness, something miraculous happens. We create it ourselves. Against the silence, we sing. Against the void, we love. Against inevitability, we dream. That perhaps is the most haunting and the most beautiful truth of all. As the journey through the scariest truths of the universe comes to a close, what lingers is not just the science, not just the theories of stars burning out, galaxies colliding, or black holes evaporating, but the heavy weight of perspective they bring crashing down on us. We began with awe, the marvel that we exist at all in a cosmos born from fire, but as we peeled back the layers, what emerged was a darker picture, one filled with inevitabilities that strip away the illusions we often use to comfort ourselves. Stars will die, galaxies will dissolve, black holes will fade, and eventually the universe itself will fall silent. Entropy is not a suggestion but a law, and in that law is the promise that everything ends. That, at its core, is the scariest truth of all. But the terror of this truth is not just about the far future. It's about what it reveals about us right now. If the universe itself cannot escape its fate, then what chance do we have? If everything is temporary, then even our greatest achievements, our art, our civilizations, our memories, are nothing more than sparks against an endless night. To confront this directly is to feel the weight of insignificance pressing down, to realize that the cosmos does not care whether we exist or not, and yet that very indifference forces us to look inward. If meaning cannot be found in the stars, then perhaps it must be built here, in the fragile and fleeting moments we share. This realization is both terrifying and liberating. On one hand, it strips away the myths of destiny, the comforting lies of permanence, the belief that some higher force guarantees our survival. On the other hand, it gives us something even more powerful, agency. If the universe offers no meaning, then meaning is what we make. If time will one day erase everything, then what we do now, in this brief sliver of existence, is more important than ever. The beauty of the night sky lies not in its permanence, but in its fragility, in the fact that we see it now, even as it fades. The beauty of life is the same, And so the conclusion is not despair, though despair is always close at hand. The conclusion is urgency. Live fully, love fiercely, create boldly. Do not wait for some cosmic guarantee of significance, because none exists. The scariest truth of the universe is that it ends, but within that ending lies the greatest call to action we will ever hear, to value the fleeting miracle of existence while we have it. We are stardust, briefly awake, aware of our own impermanence, and that awareness is both our curse and our gift. In the end, the silence will come. The stars will fade, the galaxies will die, and the universe will grow cold. But before that silence arrives, we get this moment, this improbable, fragile, breathtaking moment. And maybe that is enough, because against the infinite void, the fact that we are here at all, that we can think, dream and wonder, is the most astonishing truth of all.